Hello and welcome to the presentation on the surface area of a pyramid. If you haven't done the do now, please go into Google Classroom and do the do now. The surface area of the pyramid is our main lesson today. That's what you'll be are targeting and putting things together. You should have done the do now. We're going to do a little review on the cylinder, on how to find the area of a cylinder. We're going to take some notes in the form of practice problems. And your homework is going to be the Ed puzzle and the practice problems that'll be in quizzes. Okay? All right. Let's begin. So the review. Find the surface area of a cylinder. So in the surface area of a cylinder, we have some keywords. We have the diameter of is of 10 centimeters and the height is 15 centimeters. And then this is the part I want to bring out today in terms of pi. So whenever we have round values, we always have the term pi. So let's draw our cylinder. So basically we're doing like the cardboard on the toilet paper roll, or we're doing the paper towel roll, the cardboard on the inside of it. We're finding out what the surface area is. So going all the way across from here, we have a diameter of 10 centimeters. So that means, and then we have a height right here of 15. So the more important thing is, what is the radius? And the radius is 5. So we need to find the area of the base right here. We need to find the area of the base right here, the base down here, and the sides unrolled, and we're only looking for the surface area. So the area of the base. Now really we have the top and bottom are the same, so we can multiply them by 2. So the area 2 times the area of the base is pi r squared. So we know that 2 times pi, and then r is 5 because that's our radius squared. So we have 2 pi times 25, which gives us 50 pi. Now, the reason I didn't multiply by multiply by pi, because we want to look in terms of pi, so we're going to just leave that pi in the answer the same way we did when we did square roots. The area of the side means that we need to find the area of the side would be like the wrapper, and we need to know what the circumference is. So the circumference of our top circle is going to be 2 pi r. Again, these are formulas that you should know, but they'll also be given to you. So the circumference looks like the edge, that C looks like the edge. So that's 2 pi times 5, which gives us 10 pi. So we're going to take that 10 pi, we're going to unroll this whole thing right here. And that circumference becomes unrolled, and this becomes 10 pi, and this becomes 15. So the area of that middle part is 10 pi times 15, which gives us 150 pi. So this right here is the unrolled circumference of our circle right here. These two things are exactly the same. This circle and this side are exactly the same thing. This is just an unrolled circle, which happens to be the length of 10 times pi. So our total that we have in here is our 50 pi, which is our top and bottom area, plus our side, which is 150 pi, which gives us 200 pi, and then our units are centimeters squared. So this is leaving it in terms of pi. If you wanted a decimal value, you would take 200 times our pi button, but this is called in terms of pi. And then because this value has a pi and this value has a pi, we can add those together. All right, a pyramid. A pyramid is a three-dimensional figure in which one face, the base, is a polygon, and the lateral faces are triangles that meet at a common vertex. So what does that all mean? So let's give an example. Here's our picture. So we have a base on the bottom. It is a polygon. So what kind of polygon? This one happens to be a hexagon. And from the looks of it, and I only could go by looks, it looks like it is a regular hexagon, which means that all the side lengths are the same. So in here, the vertex that we're talking about is here at the top. That's a specific vertex. We can see that we have more vertexes for each vertexes. Anyway, these little sections right here are the vertex for each of the angles that we have, but the vertex of the pyramid is here at the top. And that's just a small point, but it is something that is a common thing that we say. The vertex of the pyramid is where all the triangle sides come together. Okay, so I have three. I'm going to use that same pyramid, and we're going to be talking about our terms. So again, going back here, this is our base on the bottom right here. So this is our base. And then we have our vertex at the top. That's what we just talked about. And then we have our altitude or our height. Altitudes and height always are perpendicular to something. So this actually turns out to be the very center of our bottom. But this altitude and height is of the whole pyramid, the whole pyramid. Okay? So those are the altitudes. If this is a regular polygon on the bottom, our altitude goes right into the center. But as you can see, it says and over here. So we're going to go and. The and is the slant height. So this is the slant height. And it's slant because the sides are, wait for it, on a slant. But it has a special letter here, which is a cursive L, which is for our lateral side or face. Lateral side or face. So that cursive L is really for lateral, but we call it the slant height to distinguish it between our altitude of the whole pyramid. Now, why am I going over this terminology for? Because a lot of times they give problems in using the terminology where you need to know what the slant height is or what the altitude or height of the pyramid is. These are two different things. So we need to know what they're talking about if they were to use it in words. Okay, let's look at a problem. When we do this, we can also open them up into a net. So this one, 1, 2, 3, 4, 5, it has a pentagon as a base right here. This is a pentagon. And then each star opens up to the sides. So we're going to be looking for the slant heights. These are all the slant height. So if this is a regular polygon, all the triangles are the same. So if this is a regular pentagon, these are all the same. So the slant height can be used to find the area of the faces. Okay, here we go. Find the surface area of a square, important term, pyramid with the base edges of 5 and a slant height of 3. So what are we talking about? Here's our example. So this is our edge right here. This is our edge. and the edge length is 5. So we go back into our term. This is where I'm talking about where the terms are important. So in here, we have a square pyramid. The square means that all side lengths are the same. All side lengths are the same. And that the slant height, not the height of the pyramid, but the slant height is 3. So in here, the area of the base is 5 times 5, or 25 meters squared. Each side has a triangle. But we're going to find for one triangle. So in here we have a triangle. We have our slant height. We have our perpendicular line. We know that this is 5. So the area of our faces is 1/2, 3 times 5, which gives us half of 15, which gives us 7.5 meters squared. 7.5 meters squared. And now because we have 4 sides, the area of all faces is 7.5 times 4, because there's 4 of them, is 30 meters squared. And then our area total is 30 plus 25, which gives us 55 meters squared. So we need to know that the slant height is on the side because it's a triangle. We need to know the altitude or the height to be able to figure out our area of our side. Okay, here's another practice problem. This one has more information in the picture. So remember, this equals inches. Okay? So that's a common thing. But look at this right here. Look at this right here. Let me see if I can highlight it for you. Take a look at this right here. This is information for us. It is not another shape. It's information for us. So if we were given our altitude of our pyramid, we could calculate the slant height. Look at that. We could calculate the slant height. And the slant height would be calculated using the Pythagorean theorem. So if we were given the altitude, we could find the slant height, but we would need to know this right here. But look at the relationship between the 10 and the 5. So if we were to put this right here, we would know that the 5 is half our 10. It's half our 10 because this drops down into the exact center of our figure because we have a regular polygon. All right. So let's calculate the area of the base. Again, it's 10 times 10, which is 100 inches squared. The area of each of our triangles, the area of our triangle sides, is 1/2 10, that's our base, times our slant height, which is 15, which gives us 1/2 of 150, which gives us 75 inches squared. We have 4 of them, so 4 times 75 gives us 300 inches squared for all faces. And then our area total is equal to 100, that's the area of our base, plus the area of each of our sides, which is 300, which gives us 400 inches squared. Now, if you didn't see this, to multiply by 4, you could see that this side right here is 75, the back side is 75, the one on the left is 75, and the one on the front is 75. And you could add them up that way too. All right, not all of the bases are squares in here. Not all of them are squares. This one happens to be a triangle. So our pyramid base happens to be a triangle. So let's take a look. Is there any information in our words? Yep, right here, equilateral. So equilateral should mean something to you. And that means that all sides are 10. Because this is 10. This back one here is also 10. So now we have two heights. We have this one right here is our slant height. That's our slant height. So even though the back triangle looks a little funky, it's because they're drawn on a two-dimensional figure. And then this height right here is the height of only the base. Only the base. So the area of our base is, because it's a triangle, 1/2 10 times 8.7. So that comes out to 1/2 times 10 times 8.7, which gives us 43.5 feet squared. And that's the yellow part here on the bottom. That's the yellow part. We have the area of our side or our face is 1/2 of 6 times 10, which gives us 6 times 10 is 60, divided by 2 is 30 feet squared. We have 3 of them because we have 3 sides, 1, 2, and 3. So the face total, here we'll put it this way. That'll probably be maybe making it a little bit more clear. The area total is equal to the base, 43.5, plus the side that's on the right, which is 30, plus the side that's in the back, which is 30, plus the side that's on the left, which is 30. And that gives us 90 plus 43.5, which gives us 133.5 feet squared. All right. Let's take a look at this one here. Notice that we have in here a base that is a hexagon. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Yeah, it's a hexagon. Oh, it says it right up here. Hexagonal prism, and we need the total surface area. So we need the area of the hexagon. And in this hexagon, it is a regular hexagon. That means all the side lengths are the same. All the side lengths are the same. So it probably should have said that in there because you can't always keep track of that. So we're just going to put that in there, regular hexagon, because we need to use that for the information. Notice we have 3 altitudes in here. We have the center, we have the altitude of our figure, of our prism, or excuse me, pyramid. We have the slant height, and we have the altitude for our base. So I put in here a hexagon so we can take a look at this. So 8 and 4. Okay, so this is our center. And we're going to go to the side, and if this is here, this is 4, and this is 8. Now remember, if you don't, we talked about this ages ago, we can break this down into triangles. Break this down into triangles. And if we were to do that, we could see that this is 8, this is 8, 8, 8, 8, and they're all the same. So we're going to take a look at this triangle right here. Figure out the altitude, figure out the area of that, and then we're going to multiply it by the number of sides, which happens to be 6. So in here, this regular hexagon is 1/2 of 4 times 8, which is 1/2 of 32, and half of 32 is 16, and I believe we're talking about inches squared. That's just one triangle. Okay, so now we have a total, the area total of the hexagon is 6 times 16, which gives us 96 inches squared. 96 inches squared. So this is our area of our base, area of base. So let's go back. So we have the area of our base is, get rid of that. Oh well. So that is 96 inches squared. We just figured that out. So each of the sides is exactly the same. So looking at in here, we're going to find, and we need to use our lateral side. So our base is still 8. So we're going to take that hexagon and we're going to pull out our side right here, and that's our side length. So our area of our face is equal to 1/2 of 20 times 8. 1/2 of 160 is 80 inches squared. So our area total that we have, that's our surface area, is our area of our base, which is 96, plus 80, plus 80, plus 80, 1, 2, 3, plus 84, plus 85, plus 86, because there's 6 sides to what we have in here. So 80 times 6 plus 96 gives us 576 inches squared. Okay. All right. So there's practice problems in the quizzes. And let me know if you have any questions.